Welcome to this last module for this course. We are going to do two things in this week's videos. One is about file input and output, that will be the first part, and later we will also learn something about structured programming. So, let me give you a little bit of motivation for the lecture itself on file I/O. So, it is not reasonable to expect a user to always give inputs from the keyboard or always just print things on the screen. There are several places and instances where you want something recorded and you want it to be reused later, and this is a place where files come into picture. It is not, the notion of files is probably not alien to you. So, what we will do in this lecture is we will try and learn what a file is and how to perform input and output operations on a file. We will also see how to write programs that will read from or write to files, and we will learn one another topic about command line arguments. So, that will be the first video for this week. So, let us look at the notion of a stream. When we look at files, things like MP3 files, video files, document files, or even HTML pages that you download, right, are all files. They have all been created somewhere. They enable you to transmit information from one place to the other, save it, retrieve it, and so on. And without files, we can't do any of those. So, if you expect a user to always give inputs over a keyboard, that is not always good. Sometimes the input is not even coming from the keyboard, it could be coming from some other device. So, the notion of a file let you both store and retrieve information, and in this context we will use this notion called a stream. A stream is essentially a flow of input or output data. These could be anything, these could be characters, bytes, numbers, anything that you send from one program to another program or from one device to another device, and so on. So, let us look at this basic example. So, let us say I write a program, and what we have been doing is we have always been taking inputs from the keyboard. Whatever I do demonstration of, I take inputs from the keyboard and the output was always on the screen, right. And when you did your programming exercises online, this input itself was not from a keyboard. You had saved something and it got saved into a file, but the output was still on your screen. There are other places. For example, let us say my program is actually an MP3 player or a CD player. The input is going to come from a compact disc and the output is probably a speaker, right, or the input stream is coming from a compact disc, and let us say you take a WAV file and you make MP3 out of it. So, the input is from your CD, you are ripping a CD and you are writing to a disk which is the hard disk. So, we need to be able to not just interact with keyboard and monitor alone, we need to be able to interact with other devices also. At the same time, we do not want to be bogged down by all the details of these devices and so on, and that is where the notion of file IOs come in, right. So, C basically has no direct support for input and output. Instead, it is supplied through a library, and we have seen this so far. The header file that we have been including called stdio.h is essentially that. So, it has several functions that will enable you to do input and output. You do not have to really remember all of them, but it is good to know that all the functions that you need for input and output are actually in this file, are all in this header called stdio.h. So, let us now concentrate on what C gives us. So, every C program is automatically associated with 3 standard streams. So, that is why you will see the prefix called std for it. So, there are 3 standard streams: std in, std out, and std er, right. So, std in is for input stream, std out is for output stream or anything that gets written from the program, and std er is for printing any errors, and it is usually associated with the screen itself. So, std in is usually associated with keyboard, std out is usually associated with the screen, and std er is also usually associated with the screen, right. And whenever we did things like scanf and getcar and so on, we were actually reading from the keyboard. So, that is your standard stream. So, you do not have to do anything specially, and output was always written to the screen also. So, with printf we did not bother what to do with it, because we know that the default stream is anyway std out, which is connected to the monitor. But when you have files that you want to deal with on your own, it is not the case anymore. So, even though std in, out and er are automatically connected, if you want to do anything more with other files, if you want streams from other places, you need to do something more. So, reading and writing a file in C requires 3 basic steps. You need to be able to open a file, you need to be able to do all the reading or writing that goes with it, and finally you should close the file. And instead of dealing with file names explicitly in our programs, we will deal with what are called file pointers. So, file pointer is essentially a pointer to a structure that contains a lot of information about the file. Again, we do not have to know a lot of details about what is in the structure, but just remember that we will deal with file pointers and not file names directly. So, let us start with the first step, namely opening a file. So, if I want a programmatic way to open a file, so it is not about clicking on a screen and opening a file. So, I want my program to be able to open a file and do some operations on it. So, to do that, you declare a file pointer and you open a file using this function called fopen. So, file pointer is declared with, as you see in the second bullet here, file star fp. So, fp star fp is indicates that it is a pointer, and to what is it pointing? It is pointing to a structure called file. So, fp is a pointer to the data type structure, and many times we will drop this thing called structure and we will just say that fp is a file pointer. Right. So, we have a file pointer now, and we can do fp equals fopen of name comma mode. So, the name should be the name of the file that you are trying to open, and mode can be one of the 3 things. So, let us see this example. fp is fopen of data.text comma r. So, if we say r, it is supposed to be in read only mode. We are trying to open the file data.text in read only mode, which means you do not want to write anything from your program, you want to only read contents of the file data.text. So, one can notice that both the file name and the mode are actually put within double quotes. So, fopen expects 2 strings, one string which is the name of the file and another string which is the mode itself. So, let us look at the other modes of opening a file. So, R I already mentioned in the previous slide. W is the other mode in which you open the file, but only for writing, which means from your program you can only write to it, you cannot go and read what is in the file. So, that is called write mode, and A, which is called the append mode. So, let us look at the distinction between among these 3 modes. R means it will try and open an existing file. So, clearly what if I try to open a file that is not even existent? We need to be able to capture this, right. So, let us say I am going to open a file, but there is no file by that name. If that happens, we need a mechanism which says there is no file by that name. So, that is an issue that we have to deal with for R. For W, you are trying to write to a file, you are not going to read it from there, at least in this program as of now, right. So, if the file already exists, and since you are only writing, the previous contents of the files does not matter, you can as well remove all the contents and start with 0 length. So, since you are only writing from the current program, if you by mistake open an existing file, the previous contents will all be deleted. But normally you would expect your program to create a new file. So, if it is a new file, and since you are writing, it will automatically create a new file with the name that you have suggested. A stands for append. Append means add at the end, and this is, as the name indicates, it is useful for writing only at the end of the file. So, clearly this is similar to write, it has some similarity with the write. If the file already exists, the initial contents are unchanged. However, if the file is not there, append is as good as actually opening with the W mode, only that all the writes will always happen to the end of the file. So, these are the 3 modes. Let us now look at how to open a file. So, we have fptr1 which says fopen mydata comma r. We are trying to open a file called mydata in read only mode, and fptr1 should be file star fptr1. In this example, fptr2 is fopen results comma w. We are trying to write something into results file, and so both of these, once they are open, you have essentially, it is like opening a gate through which a stream can flow. So, once you open a file, you can now start reading and writing. So, you can either read from the stream or you can write to the stream, and these files will remain open until you explicitly close them. So, if you do not explicitly close them, the files will remain open till the end of the program. So, let us look at how do we test for successful open. I mentioned this as a problem, right. So, I try to read a file and the file is not existent. What do I do now? So, let us see this example, file star fptr1, and you try to open my data. So, it will try and open it from the directory in which the program is running from, and if the file does not exist, fptr1 will be supplied with a value called null. So, if fopen fails, it will return null. However, if fopen succeeds, it will be a valid pointer. So, you can use this information and go and check if fptr1 is null or not. If it is null, you know that the file open failed for whatever reason. Maybe the file was not there, that is the most common reason, it failed, and you can say that file my data did not open, and you have to tell the user to input another file name or some such thing. So, unsuccessful open for read is a problem, because you cannot proceed from there if the file is not even there. Whereas, for write, fopen may not work because you do not have enough space in your disk and so on. So, there could be other reasons why fopen may fail if you open it in write mode. So, now let us look at the second step. So, we said we will open the file. Now, we know how to check the error if the file cannot open. Let us look at the second step, reading from the files. So, second step is either reading or writing. Let us start with reading. So, int a comma b, these are two integers, and we have a pointer fptr1 which is of type file star. Let us look at this line here. We have opened the file. In this example, there is no check on whether fptr1 is null or not, but let us see how to read two integers from the file. Let us assume that fptr1 has two integers, or the file my data has two integers saved in it. You can, so this line here is trying to do a scan, right, and you can see some similarity with scanf that you have seen before, right. We have been using this all along. So, let us look at this. So, it is similar to scanf, except that there seems to be three different sets of parameters. So, this is the format that you give to fscanf. So, this is the format in which you are going to read. This is the set of pointers that we are passing. So, this is very similar to scanf, except that you also pass the file pointer fptr1. So, fscanf takes three parameters, one which is the file pointer, two which is the format, three which is a set of variables in which you have to read. So, in scanf, all we have done is we got rid of the fptr1 because scanf by default always reads from stdin. So, fscanf, once this is over, it would have read two integers from the file my data. So, when you read a file, you could be writing a loop to read one line after the other. Let us say I have a file in which I have 10 lines of two integers each. I keep reading. At some point I have to find out that I have reached the end of the file, because once I reach the end of the file, for the program there is probably no processing to do anymore. So, it has processed the file, and maybe all the work that needs to be done is already done. So, there could be some other file in which there are 30 lines, another file in which there are 100 lines and so on. You need a mechanism by which you do not have to know the number of lines in the file for your program to operate. And so, you keep processing one line after the other, and at some point you realize that you have to find out that you have reached the end of the file, and that is done by C using this function called FEOF. So, if you do a scanf and let us say you are expecting something from the input stream, and if you have already reached the end of the file, then if you check on this thing FEOF of fptr1, so this EOF stands for end of file. So, in your file stream, if you have reached the end of file of the pointer fptr1, it means that whatever that file that you are reading using fptr1, you have reached the end of the file, there is no more processing to do. So, this is one way to find out if you have reached the end of the file. There is also another way in which you can check whether you have reached the end of the file. You keep reading one line at a time. At some point, if you reach the end of the file, let us say you did this fscanf fptr1 %d &var, that is exactly what we had earlier. We do a scanf. Interestingly, scanf also returns an return value. So, we never bothered checking the return of scanf, but fscanf returns a value which can be used to check whether you have reached the end of input stream or not. So, there is a special character called special value called EOF, So, this capital E, capital O, capital F. So, that is a special value. If fscanf returns this special value, then it means there was some problem in scanning, which, so it actually indicates that you have reached the end of the file. Otherwise, fscanf would return a value which is not EOF. So, if fscanf returns EOF, you know that you have reached the end of the file. So, either you call FEOF of FPTR1, or you copy the value, return value from fscanf, and you check against EOF, and it will tell you that the end of file has been encountered. So, that is one of the things that you can do in the second step. The other thing that you can do is you can actually go and write to files, right. So, for example, if you look at this code, as you can expect, this is a variation of printf. So, as before, we have two integers and we have a file pointer called fptr2. We open the results file in write mode, which means if the file exists, it will overwrite it. If it does not exist, it opens a new file with the name results. And now this fprintf is similar to printf. So, you have the format specifier, you have the parameters that are supposed to be printed, but you also pass the file pointer as the first parameter. So, this line will actually write a comma b, the values a comma b into the file pointed by fptr2, and you keep writing, and it will keep writing one line after the other till the end, till when you can, so you can stop writing. So, for example, if you have another fprintf fptr2 %d %d \n, let us say 5 comma 10, right. So, that will write one line of 5 comma 20 and another line would be 5 comma 10. You will see two lines in your file. The third and final step in having file IO done is closing the file. So, fclose of fptr1 and fclose of fptr2 will close the file associated with the stream fptr1 and fptr2. So, and whatever extra work that it has been doing, it will release all of that back to the system. So, it is important that you actually close the files, because if you actually open a reading stream, maybe it is not that big an issue, but if you have been writing to a file and if you did not close, you can run into problems. So, closing a file is important because usually output is buffered. So, what we mean by that is, let us say I want to printf to a screen, I want to do printf, it may not appear in the screen immediately, right. So, what can happen is whatever is supposed to be written could get written to the buffer, and eventually the buffer gets flushed to the actual device. So, the flushing could be to the hard disk, or the flushing could be to your monitor, and so on. So, the best example that I can give is if you use USB sticks, many times they tell you to remove the USB sticks, especially if you have written something on a USB memory drive, they ask you to eject it carefully, right. So, you would go and click on something and you would say safely remove the device and so on, right. If you have wondered what you have been doing, what it actually does is when you remove the, if you have written anything to the anything to a device, it is possible that the actual entries have not been written, the actual bits and bytes have not been written, they are still in a buffer sitting in the RAM, and only when you ask the system to be flushed, then there will be a commit to the device. So, this happens for various reasons which we cannot get into now, but if that buffering happened and if you plugged out your USB memory stick, your USB memory stick is not guaranteed to have all the data. However, if you go through your operating system and say safely eject the device, it will flush all the buffers to your device and then you can remove it. So, fclose essentially forces all the buffers to be flushed, and the device all the contents that you wrote from the program is guaranteed to be written into the file. So, there are several other modes that you can use. So, there is a mode called R+, there is a mode called W+, and another called A+. So, the plus indicates something. So, this is the reason why we have been passing it as a string. It is not just one character, at times you may have to pass more than one character. So, in this case R+, W+, or A+. So, R+ is it indicates that you want to be able to read, but you want something more from this mode. So, you open an existing file for both reading and writing, because this is also something that you may need once in a while. So, what happens is, because you are opening in R, it will not delete the file, it will not delete the contents. The initial contents of the file are unchanged, and the initial position at which you can start doing your operations will be at the beginning of the file. So, if you want to overwrite only part of the file, right, you can use R plus. You open it with R and R plus, and you can start overwriting from the top, and you can stop at some point instead of deleting all the contents. W plus is also in some sense similar to what you are doing in R plus, but there is a key difference. So, both of them open a file for both reading and writing, but W plus being this notion that you destroy the file when you open something in W mode, it does exactly that. If the file already exists, it is truncated to 0 length, otherwise a new file is created, and on this you will be able to do both reading and writing. Finally, A plus is distinct from W plus. This also opens the file for both reading and writing, but if the file exists, its initial contents are unchanged. In that sense, it is similar to R plus. Otherwise, it will create a new file. In that sense, it is similar to W plus. So, these are 3 other modes in which you can open a file. So, what we will do now is we will do a quick, I will show you a quick demo of file IO. I have written some small programs to show you file IO. So, there is this file called file1.c in which I have done something. So, I am going to open a file called mydat1.txt in read only mode, and this file is expected to have a bunch of integers, and what I am going to do is I am going to sort the numbers which are in the file, and I am going to write it to this file called sorted.txt. So, I am going to do 3 things: open a file called mydat1.txt into an array, sort the array in your program, and write the sorted results to your another file called sorted.txt. That is what this program achieves. Let us see how this is done. So, there are 2 file pointers fp1 and fp2. fp1 opens mydat1.txt in read only mode, and I also assume that the number of entries in the file is not more than 10. So, I assume that at most 10 integers are stored and nothing more. So, what I have done is I have declared an array called A of 10 in size, which means it can store up to 10 integers, and look at this line, line 21 through 24. If you 24, if you look at it, while fscanf of fp1 %d ampersand temp. What does fscanf do? Given a file pointer, it will try and use the format and read from the input stream, in this case from mydat1, into this variable called temp, right. So, when you read, it is possible that you have 10 integers, but at some point you will hit the end of the file, right. So, fscanf, you go and check, it will do this work, fscanf fp1 %d ampersand temp. So, this line actually tries and reads from a file, but if it is unsuccessful and if it returns EOF, the while loop will terminate. Otherwise, it keeps reading the contents into A, and as long as there is 10 or less lines, A will not be overrun. It will have 10 entries, so up to 10 integers from this file mydat1 is okay. Then I am calling this function sort nums a comma cnt. I will not worry about sort nums now. So, I have written a small program, small piece of code which does insertion sort. So, I will not worry about that. I will assume that A gets sorted, and I am going to write things to a file. And how do I do it? I open fp2, which is opening the sorted.txt in W mode. If fp2 is null, it cannot file the open for writing. Otherwise, you do fprintf fp2 %d a of I. It takes one A at a time and it writes it to fp2 in the format integer. And one thing you can notice is line number 25 and line number 36 closes the 2 files. So, this file you are done with reading at line number 24, you do not have anything more to read. So, you can close the first file mydat1.txt at line number 25, and since you are done with all the writing of all the variables that of all the values, you can close this file at line number 36. So, I will compile this and I will show how it is going to run. So, I have compiled it. Let me show what the file has. So, I am going to show you what mydat1.txt has. So, it has a bunch of integers. So, 20, 80, 30, 50, 70, 60, 10, 40. There are 8 integers clearly less than 10. So, I am good. So, I have already compiled it earlier. So, the executable is called file1.exe. That is what I call the file as file1.c. When it compiles, it gets file1.exe, and when I run it, by now what it would have done is it would have written something called sorted.txt. You can see that the numbers 10 to 80 were all here in unsorted order and they are all in sorted order now. So, just to show that this was actually created by the program, let me delete the sorted.txt, right, because it is a file that you are supposed to write every time the program is run. You can see that sorted.txt, there is no file by that name, and if I run the program again and see what is in sorted.txt, you can see that the file got new entries now. So, I deleted the file, and when I ran the program it created the file called sorted.txt. So, for a while let us assume that this mydat1.txt did not exist, I will instead call it mydat.txt. This was expected by the program my.1, I renamed it. Now, if I run file 1, right, so I printed this error called file not present, right, this file which is not present is my.1.txt, it would not change the sorted.txt because I exited from the program. So, this is a small piece of code that I wanted to show. I have another piece of code which is also interesting. So, it is possible that I have two files which are both sorted entries. Now, I want to merge these two files together, right. So, in the previous case, one thing that happened was I actually knew that the contents of the file had only 10 entries, but I may not know that upfront. I need a mechanism by which I do not want to depend on any count. So, in this program what it does is it takes two files, it assumes that both these files are sorted and it will try and merge these two into one single sorted file. So, we are going to take two inputs sorted 1.txt and 2.txt and we are going to write a file called sorted.txt. So, you can see that sorted.txt gets opened in write only mode, right. And if either FP1 or FP2 failed, you know that you cannot read, so it is not present. Otherwise, you scan one integer from each one of these streams. So, you have one integer in stream 1 and one integer in stream 2, you read that, and then I have written a piece of program from line number 25 to 37, right. There is a piece of program which runs on a while loop. So, what does it do? So, I have two files which are of differing lengths, it is possible that I will end up consuming everything from one stream before I even finish the other stream. So, what I am going to check is, have I not reached the end of stream 1 or stream 2? If I have not reached the end of stream 1 and not of stream 2 either, right? As long as I have not reached the end of any of the streams, then I can always read two integers and I will be able to compare them and do something with it, right. So, at this point I have two integers that I have read, I have not reached the end of the stream, which means I should be able to compare and write the results back. So, the first stream you read into temp 1, the second stream is reading into temp 2. So, you are comparing temp 1 and temp 2. If temp 1 is less than temp 2, then write temp 1 into the output file and read one more integer from file 1. Otherwise, if temp 1 is greater than temp 2 or equal to temp 2, you write temp 2 into the file and you read one more integer from file 2. So, you can see what is happening here. So, either the entry in file 1 or the entry in file 2 will be, one of them will be the larger than the other. You write that and move one step in that stream. And what could happen is, when you exit this loop, you may not have exhausted both the streams. One stream could end prematurely and the other one has more numbers, but remember that the numbers are sorted. So, I can do something like what you did in merge sort. That is what I have been trying to do here. Line number 25 to 37 is merging two streams instead of merging two arrays, but if the arrays are of different size, then you have to just concatenate whatever is left out at the end of the resultant array, and that is what this loop does. So, line number 47 to 50, what it does is so this 39 to 46 finds out which stream got over. So, if FP1 got over, FP2 should be copied. If FP2 got over, FP1 and to the end should be copied. And what line number 47 to 50 does is, it just copies whatever is left out in whichever file it is, and it keeps scanning and keeps copying till the that file is also exhausted. And once that is over, we can close all the streams FP1, 2 and 3 and you can return this 0. So, let me again compile it, and there are no compilation errors. So, let us look at sorted.text because that is the output we are going to write. So, it has 10 to 80 now, but let us look at sorted1.text which is one of the input files. It has 10 to 70 and sorted2.text I created with more values than sorted1.text. It has 5, 15, 25 all the way up to 105. So, there are 7 values here, but there are 11 values here. So, your program will finish this stream before it finishes this stream. So, you will have more work to do after this stream is processed. So, I will run file 2 now. So, I ran file 2 and it was printing various things on the screen. Now, let us go and look at sorted.text. So, it got overwritten first. Sorted.text was earlier written by file 1.c. Now, I have file 2.c, this is the second program, and it overwrote the sorted.text. Now, you can see that the entries of the resultant file are in sorted order. So, we read 2 files. The key thing I want you to see is this FEOF is another way to look at end of file, and in this case I am simultaneously forwarding both the file pointers by. So, I am trying to see if either one of them reach the end, but one of the file pointers will move inside the loop, either this or this will move depending on which one was lower. So, let us get back to the presentation. Okay. So, we looked at 2 examples in which we read and wrote to files. The other key thing that I want you to learn is the notion of what are called command line arguments. So, if you notice the things that I have been doing here, right. So, let us say I want to copy file 1.c to another.c. So, I wrote this thing called it's called copy, right. So, copy is a Windows command to copy one file to another, but copy itself is a program, right. Somehow I am able to pass values file1.c and another.c here, and I am able to get copy to do some work. I did not say copy and then I typed file1.c in keyboard and another.c in the keyboard and so on. When I launched the program itself, I was able to give the parameters that it's needed, and the copying got done, right. So, this is called command line parameter. So, we are in a command line, we are calling an executable and we have given 2 parameters file1.c and another.c. We want to be able to process command line parameters. That's the next part of this video. So, command line arguments work like this. You can pass arguments to C programs by passing them right when the program is executed. So, you can sit in the command line and type along with the parameters that you want. You do not have to type them in later when the program is running. So, for example, if you typed echo hello comma world, then you would see hello world printed on the screen. So, echo is actually taking command line parameters hello comma and world, and it is processing it, and it actually is printing on the screen. Right. So, this is done using a very sophisticated mechanism. So, you remember the main program does not take arguments by default. So, we never used, even though I said main is a function, we never passed any arguments to it, but you can actually pass 2 arguments, int argc and character star argv of array. So, argc is an integer, whereas argv, if you look at it, is a pointer to a pointer. So, it is a set of pointers to character pointers. So, argv, this square bracket means it is a set of pointers, and what is it pointing to? It is character star. So, it is a pointer to pointer. So, you can also think of it as an array of strings. So, argv of 0 is usually the name of the program, argv of 1 is the first argument that you passed, argv of 2 is the second, and so on. So, argc is an integer value that takes the number of arguments including the file name itself. So, for example, if I did copy file1.c another.c, this is there are 3 arguments, copy file1.c and another.c. So, argc would be 3, argv of 0 would be copy, argv of 1 would be file1.c, and argv of 2 would be another.c. So, what really happens is you get argc equal to 3, and argv is a pointer to a pointer, and what do you have? You have 3 pointers which are pointing to echo, hello and world. Remember, these are strings, so you have a \0 at the end, and the 4th pointer actually points to null. So, you have in some sense a 2-dimensional array of characters. Again, as before, I have written a small program which does something very simple. So, it takes argc and character star argv. All it does is it iterates over all the arguments and prints them on the screen. So, it prints what is the argument number and what is the value of the argument. So, I runs from 0 to less than argc. So, it goes 0, 1, 2, 3 up to argc minus 1, and it prints I comma argv of I. So, I have already compiled this program, let me run it now. So, I call this program echo, right. Let us say I typed only echo.exe, I did not pass any parameters, it just gives me the 0th argv, which is echo.exe itself. Let us say now I give echo a, right, a is one of the parameters. So, this is the 0th argv and this is the 1th argv, so you get those two. I can pass an arbitrary number of inputs, see this. So, you have 0, 1, 2, so you have 3 arguments echo.exe a and b. I can do this and so on, right. And it is not necessary that you pass only one variable type. I passed an integer here, then I can pass a real value here, you can do any of those. So, anything that you pass in the command line will be passed to the program as argv. So, they are treated as strings inside and I am printing one string after the other. So, this comes in handy whenever you do not want the keyboard input at all from the programmer, even to read a file name. Let us say I want to write a program like this, copy file1.c to file2.c. So, I do not want the user to type it later, instead I want that to be given in the command line itself, and automatically this file. So, you will treat that as a string, you have to open the file by that name, read it, open the other file in write mode, write it and so on, all of that is there, but you have passed the file names right in the command line itself. So, these are two things that are very useful, the notion of being able to do file IO and the notion of being able to take command line arguments. So, that is the same program that is here, and this brings us to the end of this module.